Welcome. This video introduces some of the trickier points of multidimensional arrays and using them in Qt Creator. So a multidimensional array, right, we have more than one dimension, something like rows and columns, or even 3 or 4 or 5, as many dimensions as we want. And we like to think, right, we do this so that conceptually we can think of something like, well, I want to access scores row 4, column 0, right, that particular one. Or I want to print out the second row, first column. And think of this as being structured in a 2D grid or a 3-dimensional cube or however many dimensions we have. But behind the scenes in memory, right, main memory is essentially just a list of storage boxes. And so something like this 2-dimensional array gets turned into a 1-dimensional list in memory. And the way we find a particular thing in the list is we look at the row number, so row 1, and using that and the number of columns in the array, we can skip ahead the right number of steps. So if I know that there's 3 columns in this array, and I want to access column 0 of row 1, I can do 1 times 3 to get the right offset for the row, and then plus the column number 0, so it tells me that's right at location 3. Let's say I want to find this square, row 2, column 1. I do 2 times 3, because there's 3 rows, that's 6, plus the column number 1 is 7. Right? That's where this piece of data is. So this row number, kind of the only way we can use that to find where the row starts is if we know exactly how many columns there are. And that's going to come in very important in just a minute. Now, anytime you're traversing a 2D array, if you want to kind of traverse both dimensions and hit every cell, you're generally going to want 2 loops, nested loops. For every row, from 0 to the number of rows. For every column, from 0 to the number of columns. Do something to the particular row and column. And the indexes are always row first and then column. Right? That first dimension we generally think of as the row, that second one, the column. Now, you will see, I would encourage you to, if you're writing something like this, to use row and column number as your counters. Makes things a lot more readable. But you will see most people just use I and J. And so if you see I and J, focus on the fact that the outside loop is, or whatever we're using for the first index into our array. So in this case, the outside loop, that's kind of the rows. And whatever we're using for the second one, that's the columns. There are some kind of slight performance differences between going through each row and each column. So the standard way to do it is go through the rows, unless you say want to total up each column, then you might reverse the order of these 2 loops and say for every column, go do something to every row. If you only care about kind of traversing 1 dimension, so I want to go through and only add up the numbers in the second row, then I'd need to visit every column, so from 0 to the number of columns, in the second row. So the row index is always going to be 1. The first row is index 0, second row is index 1. If I want to add up everything in the first column, well, the column index is always going to be 0, and so I just need to loop through every row and access column 0. For either one of those, I don't need a nested loop because I'm only going through 1 dimension. Say I want to sum every column in this. So I want to sum up this column, and this column. Right. Here, the major kind of unit of work is going through each column. So the outside loop would be, let's start with a column. I'll initialize a total to 0, go through each row and access the current item in the current row and column and add that to the total. And then I can print out what the current total is, come back up, start the next column. If I want to total each row, it'd be the same exact recipe, only I'd switch. The outer loop would be the rows, and the inner one would be the columns. Now, if you write a function that tries to take a two-dimensional array, and you try and do it like we would a one-dimensional array, so this function that's supposed to add up everything in an array, you will get a compiler error. And the compiler error will say something about declaration of A as multi-dimensional array, so there it is, must have bounds for all dimensions except the first. We're not allowed to kind of leave this open-ended. The only index that you can have kind of unspecified, or the only size for a dimension you can have unspecified, is this first one. And that's because this trick of bouncing to the right place in the array, remember, depends on knowing exactly how many columns there are. Right? This is going to fall apart completely if we don't know explicitly how big that thing is. So if you want to pass in a 2D array, you absolutely have to specify the second dimension and the third and the fourth, and any other dimensions there are. Now, so this would compile, but we don't like having magic numbers, hard-coded 4s in all over the place. It's better to have a defined constant for something like that. So what we'd normally do is kind of define a global constant. And remember, global variables we do not want to use, but constants are okay because they can't be changed, so they're much safer. And we use that to set the size of the second dimension and to control the loop. And down in main, we could use that to build our array and declare our array. Now, if you're bothering to make a constant for this, and essentially you're already locked in on the number of columns, we can be flexible with the number of rows and specify that as a variable. But oftentimes, if you're dealing with a 2D array and you're locked in one dimension, you end up accepting that you're going to be locked in both dimensions. And so it's not uncommon to see, for a two-dimensional array to just say, hey, we're defining it. It only works on this particular size of array. We've got that defined as constants. If we need to rewrite this program so it can handle more rows, we'll just change that constant. And now this function will work for a 5x4. Now, we're going to look at this in the debugger real quick. So we define this matrix, 1, 2, 3, 4, and is the first row, then 20, 10, 20, 30, 40, 100, 200, 300, 400. And we're going to pass that into the sum function, which is going to take it in, loop through every row and every column, add that particular value to the total, and return the total. So add up all those numbers. I'm going to put a breakpoint, so we stop right there, and hit F5 to start debugging this. Build it first. Alright, so we're paused right here. And you can see array shows me 1, 2, 3, 4. Well, that doesn't look right. Right down here, we've got 3 rows, 2 dimensions. I'm going to kill it for a second. And so let's put a breakpoint here, kind of right before we get to the function. So before we go into this function, I can see that matrix has 3 rows. So when I pop it open, I see the 3 rows. And I can see its type as an int array with 3 rows and 4 columns. And each one of these is the rows, and I can see that each one of them has a length of 4. So 1, 2, 3, 4, 10, 20, 30, 40, 100, 200, 300, 400. So that looks fine. But now if I step into the function, so I'm going to hit F11 to go into sum, and we look at what happened to matrix when it got passed in, all we see in here is that it's an int of size 4. An int array of size 4, and I only see the first row. Remember, when we pass an array into a function, we kind of lose the information about how many rows it has. So the way to fix this is the same way with a single dimensional array. If I want to see the whole array, I have to change the display format and say, you know what, display this as an array of 10 items, because I know that's enough to show me the 3 rows I care about. And now I can go peek at, okay, the first row is 1, 2, 3, 4, next one is 10, 20, 30, 40, etc. And these ones I know not to go look at because they're going to be garbage. I can also do the same trick with, I can insert an expression evaluator like we did with single dimensional arrays, and I could say, I want to see array, row, and column. Those are my 2 counters. And so right now it tells me there's no such thing because I haven't initialized row yet. So we're going to go ahead and kind of step in a little ways. And so now I can see that array, row, column, the current element is 1. And if we step forward a little bit and go to the next number, it's 2, 3, 4, and then we go to the next row, we hit 10, etc. So we can use those same tricks to track what's going on with a 2D array inside a function.